Hey, everybody! We are officially in Chapter 8. We're going to be looking at how to graph quadratics. And quadratics are just forms of polynomials, so basically graphing some of the easier polynomial functions. Let's see, start off with black here. Basic facts about quadratic functions, so kind of like vocabulary for you. It is a polynomial of degree 2. So if we remember what degree means, it means that the highest exponent of the variable in one of these equations is going to be a 2. So something like x squared. That's the kind of thing we're going to be looking at. See, like y equals ax squared. It is written in the form. The ones that we'll be looking at now are a little bit simpler. They'll say, y equals ax squared. But as we progress, we'll start to see other terms in there, like a different number times x to the first, and a last number times x to the 0 or 1. So it's in this form, which is standard form. The U-shaped graph, so this type of thing, this U shape is called a parabola. And the highest or lowest point on it, so you see here that has a low point, here it has a high point, where the whole thing kind of turns, that is called a vertex. And the line that splits it into two equal parts, so let's say, I have a line that comes down here, and that kind of cuts the whole thing directly in half, so it's symmetrical on both sides. The name of that line, quite fittingly, is called the line of symmetry. Or sometimes referred to as the axis of symmetry as well. Line of symmetry, axis of symmetry means the same thing. Okay, so we have some new information, some new vocab words, and let's just mess around with those for a minute and make sure that we have a clear understanding of that. So if I look at example 1 here, part A, vertex. Okay, up here we said that the vertex is the highest or lowest point. On this graph, it looks like it's going to be going on forever up here, but it does have a lowest point, and that lowest point is going to be right there, which would be at the point 2, -3. Okay, what about the axis of symmetry? Axis of symmetry, line of symmetry, I kind of already had drawn it before. So what's an equation that represents this line? Well, it's a vertical line. We know how to express vertical lines. They're always, x equals, and then wherever we want it to be. And it looks like this is at 2. So x equals 2 is my axis of symmetry. And then domain and range. So let's start with domain. Domain is x values. So if I go all the way to the left here, I'm looking at all negative x values. Does it look like I'll touch them, seeing as how this graph is going to be continuing on to the left and up forever? Yeah, I mean, it seems like I'm going to cover all of these at some point or another. And if I were to move all the way to the right, with this graph going up to the right, up and to the right infinitely, yeah, it looks like I'm also going to be covering all of the positive values, so the domain should be, all real. And what about the range? Looking at the y values. If I go all the way up, and I'm looking at all the positive y values, does it look like I'll hit them? Well, yeah, I mean, the graph is infinitely going in the positive direction. So it's definitely all positive numbers. Now what about when I go this way? Oh, hold on. It looks like I kind of cut off at -3. My graph comes down, and then it hits -3 and turns around. So I'm never going to have any of these things like -4, -5, -6. Even something like -3.01 will never exist. So that's going to be, we're going to have to change that range to be a little bit different here. We're going to do -3 to positive infinity. And those are the points that'll be covered. From -3 all the way to positive infinity. All those y values will be covered. Alright, try out part B. When you're done with part B, we can move on to the next page and start talking about how do we graph these sorts of things and what changes when we change certain parts. Alright, good luck! Okie dokie, now that you've done that, hopefully, and if you have not, please pause and go back. But let's move on to example 2, which is where we're actually going to start graphing some of these things. And you know, the easiest way to graph a function, like the simplest way, the way that we always start with, is by making a table of values. And we will move past that, but we need to start with a table of values since we don't have any other information to go off of. So this is a really simple equation, y equals x squared. It really doesn't get much simpler than that, and this is actually called the parent function of the quadratics, because it's kind of like the starting point, and then we can kind of shift and move and change things from there. So let's plug in some values and see what we get. -2 squared gets me 4, because it's -2 times -2. -1 squared, it's -1 times -1, which gets me a 1. 0 squared, 1 squared, 2 squared. So automatically, what are you noticing? I'm at 0, 0, and then I go 1, 1, 4, 4. There's already symmetry there, and you can see that. So if I plot this, I go 0, 0, I can go 1, 1, 1, I can go -1, 1, I can go 2 and up to 1, 2, 3, 4, and I can go -2 up to 1, 2, 3, 4. Alright, so now if I were to try to draw a straight curved line through this entire thing, I'm going to get this parabola shape, this U shape. And you want to try to draw the curve as smooth as you can without putting a point down here. You know, I obviously didn't do a very good job with that, but you want it to be as smooth and U-shaped as possible. Alright, and now let's take a look at you know, y equals 2x squared. Okay, how is this going to be different? Well, I'm pretty much going to have the same numbers as up here, but every single one of them is going to be multiplied by 2. So originally, I had just x squared up here, but now all those numbers I'm going to multiply by 2. So if I'm putting in a -2, I said up here that when I squared I get 4, multiplied by 2 is going to give me 8. Up here I said when I have a -1 and I square it I get 1, and I'm going to multiply it by 2, so I'm going to get 2. 0 is just 0. And I'm going to do the same thing again. 1 multiplied by 2 is a 2. 2 squared is 4, multiplied by 2 gets me 8. So again, I see that symmetry. 0, 2, 2, 8, 8. Alright, so let's take a look at what this looks like. Again, 0, 0, 1, 2, -1, 2, 2 up to 2, 4, 6, 8, and over on the other side. Okay, so let's see if I can draw a better curve this time that's not so... missed some points. Either way, what do we notice that's different? Okay, if I want to compare to the graph of x squared, what does it look like changed? Hopefully you can recognize that we're seeing kind of like a more steady, not steady, but more rapid increase here than we would see up here. If I were to continue on, this is gonna, you know, move over, this is gonna move over, and it's going out. It's a little bit more wide, it's a little spread out. This one's a lot more vertical and more condensed and squeezed together. So it looks like this 2 out front did a little something and made the kind of the slopes on either side, even though they're constantly changing, it made those slopes increase more rapidly. What I would like you to do is try out C and D, and yes, I know you're going to be freaking out because I gave you the fraction problems, but try out C. Actually, you know what, I'll do C with you, and then you can just do D. Yes, you're welcome, please. save your praise for in class. It's fine. So let's put in some values. It's going to be 1/3 times the x squared value. So 6 squared, what's that? Well, this is actually negative 6 squared. That's going to get me 6 times 6, which is 36. And then I need to divide that by 3. Alright, so that is going to get me 12. I'm going to do 3 squared, which is 9, divided by 3. 0 is always an easy one. And look at this, I get the same symmetry on this side. And the fraction wasn't that bad. Okay, now let's take a look and let's plot some. I get 0, I'm going to go 1, 2, 3, and up 1, 2, 3. I'm going to over 1, 2, to 6, and then up 3, 6, 9, whoa, all the way up here. And again on this side. There and there. Trying to draw a nice curve. Hey, that one wasn't that bad. Nice. So how does this one relate to x squared? If I move back, how does it relate to this one? Boom, 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 boom. This one actually looks wider. So it looks like this 1/3 made the whole thing wider rather than last time when I had a 2 and it made the whole thing narrower. Okay, now you can try doing the 1/2, and keep in mind that this is negative 1/2, so it might be a little bit different. Try it out, see what you get. If you do not get a U-shaped graph, you know that you did something wrong. So if you don't get a U shape, recheck your points. Don't just stop and say, oh, I didn't get it. Recheck your points, and I'll check in with you next class. And then see if you can answer this question at the bottom. What is this a value doing? When I had a 2 here, it did something. When I had a 1/3 here, it did something. What's it going to do with the 1/2? And see if you can come up with an idea. What certain numbers do what to the graph. All right? We'll talk about it again next time, and good luck.